Our next feature in Java 11 is running a Java file with a single command. In Java 11, we can run any Java file using a single command without any explicit compilation. This feature is known as single file source code programs. This command will automatically compile and execute the Java source file if the compilation is successful. It will run the main method in the Java class. Let's see one simple example how we can run a Java file. So here we can see one hello world program in which I have a main method which is public static void main. Here it is printing hello Java 11. Let's add some more text to this. Hello Java 11 from command line. Now I need to go to my terminal and I need to go to the path in which this file exists. So it exists in this org.example folder. So in CMD I am in this folder itself. Now I just need to use Java and hello world.java and need to press enter. So I can see the main method is running and it is printing the message which I have edited. So this is how we can run any Java file in Java 11 using a single command. Now let us go to our next feature in Java 11. Java 11 introduced a new feature known as nest-based access control. This feature is added to improve the encapsulation of classes which are logically part of same group. In this, it allows classes to access private member of each other in the same nest without the need of compiler or JVM modification. Here in Java, nest refers to a set of classes or interfaces that share the same level type. That is why we can say members of nest can access each other's private members. Let's see how we can define nest-based access control feature in our Java code. Here is the example of nest access in Java 11. Here I have defined one class, outer class. So let's see what is this outer class. Here is the definition of outer class. So it consists of a private field which is type of int and it has a setter set private field for this private field. After this we have this inner class and it has a method access private field which is printing the private field. Now let's go to next line of our next access example. Now let's see how we can access the private field of a class through inner class. So here in outer class I have defined this private field and I am setting this private field with the help of this set private field method. I am passing value 2. Now I am creating the object of inner class and I am calling the function of inner class that is access private field and I am printing this field. Now let's run this program. Now I can see that the value of private field is printed in method of inner class. This is how Java has introduced this feature nest access based control. Now let's see the next feature of Java 11. Java 11 added HTTP client with support of HTTP 1 and HTTP 2. So HTTP is our hypertext transfer protocol. So it helps in web development. Java 11 introduced this new HTTP client API that supports both HTTP 1 and HTTP 2 protocol. In Java, we have package java.net.http, which provides a modern and flexible HTTP client that can be used for making HTTP requests and handling responses. So Java 11 by default support both HTTP 1 and HTTP 2. This client will negotiate the protocol with server based on their capabilities. Now let's see how in Java 11 we can code for this new HTTP support. Here is the example of HTTP client. In this, we can see that we are using the package java.net.http. In this, we can create a HTTP client with the help of HTTP client dot new HTTP client method. It returns me a HTTP client object. After that, we can create a URL with the help of URI dot create. In this example, I am using this example.com API. After that, we can create HTTP request new builder with URL and type of HTTP method. And by using build method, we can get the HTTP request object. And we can use this HTTP request object for sending the request. So here HTTP client object has send method and we can define the type of response we want. So it is returning me a response of type string HTTP response. In this, we can get the status code and body of our response. Now, if I want to define the type of HTTP version, in HTTP request.newBuilder method, we have a method called version. In this, we can define HTTP 1.1 and HTTP 2 versions. So let's define HTTP 2. Now let's run this program and see the response. Here we can see the response of our code. So status code is 200 and response body is a HTML page. So this is how we can create a HTTP client in our Java 11. So this is how in Java 11 it supports the creation of HTTP client. Earlier we were using third-party library for this. Now we can do that in Java 11 also. In Java 11, there's a new garbage collector is introduced, which is known as Epsilon no-op garbage collector. Epsilon is not a traditional garbage collector. Instead, it is a garbage collector that does essentially nothing. Its primary purpose is to provide a no-op garbage collector for scenarios where the overhead of garbage collection is not desired or needed. Following are some features in Epsilon garbage collector. It does not perform any memory reclamation. It does not impact the heap or collect garbage. Objects are allocated in the heap, but there is no mechanism to free up memory occupied by unreachable objects. Epsilon is designed for use cases such as to measure application throughput and latency without any interference of garbage collection pauses. It is useful scenarios where memory is abundant and the application's memory footprint is stable. We can enable Epsilon by following command line options when we are launching our Java application. So we can use of Epsilon GC command line option. Also, we can ex add few additional command line options in Epsilon to configure its behavior, such as specifying a heap size. So for specifying heap size, we can use max RAM. Here is the example of how we can use our main class using Epsilon GC. Before using Epsilon, we should consider a few points. Like, since Epsilon does not perform any garbage collection, it does not identify or clean up memory leaks. Applications using Epsilon should be carefully monitored for potential memory issues. Next, Epsilon is considered an experimental feature and is not recommended for production use. It is more suitable for research, performance analysis, or specialized scenarios where garbage collection pauses are unacceptable. In Java 11, our next feature is flight recorder and mission. So first let's talk about JFR, that is Java Flight Recorder. JFR is a profiling and event collection framework which is built in JVM. It gathers detailed runtime information about the JVM and the application running on it with minimum impact on performance. JFR is designed to have low runtime overhead, make it suitable for use in production environments. It can be configured to continuously collect data about various aspects of JVM behavior. It also provides a rich set of events, including garbage collection events, method profiling, thread activity, and many more. It can be configured and started using command line options or programmatically through the Java management extensions. To enable JFR on a running Java application, you might use command like this. Next is JMC, that is Java Mission Control. JMC is a set of tools for monitoring, managing, and profiling Java applications. It includes a graphical console for viewing and analyzing data collected by JFR. It provides a detailed view of events collected by JFR, and it allows for creation and management of custom templates for JFR recordings. JMC helps in identifying the memory leaks in the application. JMC can be launched with the following command. JMC also provide a graphical interface for analyzing the record events, visualizing memory, thread activity, and many more. So this is a example image of JDK mission control. So guys, here ends our Java 11 features. I hope you like this Java 11 videos. Please like, comment, subscribe, and let me know if you have any doubt. You can post your doubts in the comment section below. Thank you.